Hey everyone, thanks for tuning in. This is my take at BigQuery's AI Hackathon 2025. This is Queryosity Kill the RAG. So, how do we have a smarter enterprise search with BigQuery? I'm gonna go on with my goal and the approach that I took. How did I use BigQuery AI and ML and the whole process that I worked on, some feedback while I found using BigQuery, and what can be done more in this pipeline. So a brief introduction about me. I am Gajula. I am currently based in Houston and I have a master's in data science and I'm currently working as a data scientist at TGS. So that's just a little bit of me. So yes, let's go ahead and change the way enterprise search works. So before I go ahead and explain what I did and my architecture, let me sort of explain what I'm trying to do for this hackathon, right? So when I think of enterprise search, all I hear these days is, okay, let's do RAG, right? Let's do RAG, let's retrieve the top K documents, give it to an LLM, process the whole context, and then summarize and give you the answer. So the problem with RAG, at least that's what I observed, is oftentimes you get a lot of irrelevant things, and in a context of enterprise, when you have so many teams and so many organizations within one big company, what happens is a lot of documents sort of overlap, and while you're searching for something you might end up getting something else. So the re-ranking nowadays is being done by a few LLMs and all, and I think it's not scalable, and I think there is a much more scalable solution that is with using BigQuery, and I'm gonna show what I did. So the first part is data ingestion, extraction, and loading it into BigQuery, and then having an agent with the BigQuery tools to be able to access the data. And yep, here we go, we have access to information and much more. So how do we do this? When I say data ingestion, what data am I talking about? It could be any data, right? So in terms of enterprise, we have a lot of text files, PDFs, sometimes videos, MP3 calls, internal memos, and so on. So my goal is to find a public dataset which is sort of similar to this massive PDF scale. So what I did is I have a public dataset, the material contract corpus from Stanford University. So this contains about 1 million files all the way from 2000 to 2023. And what I focused on was, due to the scale and the costs, since it's just a hackathon on my personal project, I just focused on the year 2020, and it's about, I think, 40,000 documents in total. And I have transferred them onto my cloud storage, like I was talking in my presentation. And then I extracted all these details into a semi-structured format. I'll walk over through what I did, and then I have them ingested in BigQuery. And once I have them in BigQuery, I have an SCC filing agent, since that's the dataset I was working on, and I have added some context for that agent to be able to use this BigQuery tools. And then I have a web app to actually have the answers that I want, right? So this is sort of the workflow. And what I did so far is, let me go through the code base. So I have actually written the source of the public document data that I used, the goal that I'm trying to do, the problems that I have, and how did I use BigQuery's AI generate table, generate boolean, and so on. So this is just the exploration notebook that I have. I wanted to actually understand BigQuery's capabilities and its nuances before I jump into the solution. So what I did is I went through the example notebooks provided by BigQuery and Google Cloud, and I have played around myself with that, right? So what I did is I created a dataset, and it sort of follows the schema. Since the data that I am working on is contracts, so this is the initial schema that I came up with, just to create the table and play around with it. So since this is actual PDFs and text files that I'm dealing with, I have created an object table to actually see how I can access GCS objects and object refs and so on. So this is just my take at that, and also how can I use AI generate and AI generate table with those things, right? So this is just a sample query scripts at AI generate on using an AI connection with Flash, because it's currently even 2.5 is better. For just experimentation, 2.0 Flash was good enough for me. And I read the documentation and found that the prompt takes a lot of weightage in how the model sort of steers itself. So I have also played around with Pydantic and Langchain prompting. And this is AI generate table. So once this is done, I have some feedback which I'll leave it to the end. But this is how I actually understood AI generate and AI generate table. And once I understood these functions, I sort of have an idea of what I want to do. So what I want to do is, instead of using AI.generate table at the beginning of the my pipeline, what I used is I have an ingestion pipeline which actually uses Gemini to parse these documents and then put it in BigQuery. So the reason I'm going with Gemini and not AI.generate table directly is because I felt like I have much more control doing that through Gemini instead of doing through AI.generate table at this moment. Because what I observed is, even though in the background I think it's using a batch prediction, the problem is I don't have control or any sort of progress of what's happening. And for experimentation or for trying out different JSON responses, Pydantic prompts, I didn't have much control for like a large scale ingestion with generate table. Generate table is awesome at deriving a few key details that I want from a set of contracts. But let's say when the scale is at like 100,000, I wanted much more control. So that's the only reason I went with an actual contract schema and an extraction pipeline, which actually goes through all the GCS files that I have, lists out and puts it in this table that I want. So the table that I'm talking about is, let me go to my BigQuery. Yes, this is my exploration where I use the model and contracts and the object table. This is the big leg object table. This is the actual contract schema that I came up with. And this is just a small preview of how I extracted the documents and put it in here. So there is a little contract summary if in case people are actually viewing and just want to sort of read through before they're clicking on this URI. And I have a view where I actually used object refs to actually use AI.generate and generate table. So so this is just the walkthrough of what I did. And what I did is, okay, great, right? I have ingested all the data. I have a view which also contains the object ref. Now, what I did is I tried with actually using a few queries. Let me go to my object ref, right? So what I did is, okay, now that I have everything, I created the object ref, and then I actually used AI.generate with object refs. I was able to get the clause explanation. That's what I'm trying here in the output schema. I was able to get that, and with the other things, I was also able to get that with AI generate, right? So the thing is, I want to use BigQuery, but I don't want to be writing SQL queries all the time, because I think if I have an agent in front of it, the agent will write queries for me, and I will be getting access to information. Because in an enterprise, most of the people might not be as tech savvy, and although we want to use the technology of BigQuery and all its AI capabilities, I think it's better to understand the user from a user perspective and be as simple as possible. So what I did is I used Google's agent development kit to create an SEC agent, and I have a prompt which basically has some few short examples of AI generate and AI generate table, and I created a fast API to expose that agent. And I also have a very simple web app which uses React and basically interacts with the fast API that I have got going, right? So a small demo of what I have here is, okay, where is my app? Yes, BigQuery Assistant. So I think the app is running. Let's maybe try and see what's happening here. So before I jump in, I'll just say what's going on here. So this is very simple web app that I just spin up in a day. I should have started the hackathon a bit more earlier, but here we go. So yeah, hey, I'm a SEC filings agent. It has access to BigQuery tools, and it's asking me how can I help, right? So let me get me contracts of Tesla, right? So this will actually go and get the SEC filings of Tesla, and so what I also spend time on is actually letting the user know what the assistant is doing behind the scenes. So this is sort of the grounding that I have. I know we have grounding in Google Cloud where they show the RAG engine and the sources, but this is my take where it actually shows the exact BigQuery SQL that it ingested. So this is my project, the data set and the view, and what it's doing is it's doing a very partial search for Tesla, and what it found is, okay, I have a few contracts for Tesla, right? And the initial summary that we got and the parties and so on. This looks like a loan agreement. Great. So now how can I use generative AI.generate or AI.generate table to actually get this, get the information that I need in these data sets, right? So what I'm going to do is like, okay, can you derive the interest percentage from these contracts? So while it's running, let me actually go on to my architecture diagram, right? So maybe now, since I have this walkthrough, maybe it's a bit more clear of what I did. I have the cloud storage, Gemini, BigQuery, and having an agent, because not everyone is tech savvy in the enterprise, right? People want to be just simple, be talked to it. It's like Google, right? Accessing information, but in a much more scalable way. Okay, let's see what it did, right? Okay, what did it do? Gemini interest percentage. See, so it actually did it, right? So a.generate, and then so it says, oh, it was not mentioned. Oh, maybe it is not mentioned. Maybe let's try something so to actually showcase that it works. Maybe I'll ask, can you derive the location from the agreements? Right, so maybe at least, because I see that is Tesla Shanghai, and I'm hoping that there will be data, of course, right? So I mean, loan percentage, it was not mentioned. That's fine. Maybe the data itself doesn't contain. So I can actually see what's happening here. So this is the tool output. So Tesla supplement agreement and the summary, the contract summary, and the interest percentage. So we actually did well with the SQL, but I don't think we got any. Okay, let's see what we have. So what did it do? Execute SQL, right? So, oh, it actually, maybe I should say to use generative AI SQL. Okay, yeah. Okay, do a sentiment analysis on what you think of the agreements. Since there is a state of incorporation and other things, I think the model went into getting the state of incorporation and so on. So maybe I asked, do a sentiment analysis. So it would definitely do the tool call, right? As I don't have permission, but I can analyze the documents. Let's see what it tried to do. Okay, it tried to do AI.generate. What is the sentiment? Written positive or something. And then what we got is neutral. Oh well, it's just a loan agreement. So yeah, but this is what we can do with BigQuery, and I think this is much more scalable than RAG, because what we are essentially doing here is, let me go back to what I want to showcase, right? So what we are actually showcasing here is that we are using AI.generate and AI.generate table, and any functions that might come in the future, the user doesn't have to worry about it. The model itself will take care of it. But are we using BigQuery? Yes, we are using BigQuery. So what happened here, right? So we actually got information that we want. We can actually ask questions that we need, and we can always go back and search for something else. Can you get me contracts of Insperity? I hope I'm spelling the company's name correctly. I just saw it while I was working on that, so I'm pretty sure I knew. Let's do this. I actually put Gemini 2.5 Pro as the agent, and it can think a lot, and also, yeah. So I think what it's doing is, yep, it's writing queries for me. Restricted stock unit, amendment, award. So yep, I actually got the documents that I want: Insperity Incorporation, employment. And this is a way to interact with the data that you have and use generative AI capabilities. So this is my project, and coming to the feedback, let's go to the BigQuery's view, right? So what happened is, when I was running a few queries, I think probably today or maybe even before, yeah, there are a few stopped. So what happened is, I was running a few queries. Let me actually click on the job. I was actually running a few queries, but I didn't limit. And what happened is, it started to go on and basically apply AI.generate table on the whole thing, right? And I have, in this case, I have like 3,500 rows, right? But let's say if it's 100 rows or a million, right? I'm not sure what's gonna happen there, and I wanted to have some control on where I can stop it, but I couldn't stop it from the editor itself. I had to go to my notebook, use a Python client to stop it. Maybe I just couldn't find it somehow, or yeah. And where other cases I was able to successfully get some things going on. I just wished there are some more information on the query itself. For example, number of tokens processed, so that I have an idea of the costs, or like per query how much tokens actually have spent, right? So that is one of the feedback that I have, and yeah, we can do much more in this, right? So the data set is public, and this is the steps they did, and I think I'm hopefully going on. Yeah, I think I have covered most of the things. Thank you so much, BigQuery team, for providing this hackathon. It was a really fun thing for me to work on, and I really believe that we can scale enterprise search. All we need to do is similar to RAG engine, how we connect data sources. I think we need to have a similar set of mechanism to be able to intelligently schematize the data sets that we have into BigQuery, and then having an agent in front of it to actually make it accessible to all the users in an organization. Yeah, this is the hackathon idea that I have, and yeah, Queryosity killed the rag. Thank you so much.